Sometimes we're keen to find out whether a function is continuous at a particular value. And this is the definition of what we mean by a continuous function. So f of x, which is just a function of x, is continuous at x equals a if all three of these criteria are true. So you must meet all three. Not one of them's not good enough, two's not good enough, all three must be true. And these three criteria are that if you can find out f of a, if that does exist. Number two, that the limit as x approaches a of f of x exists. And thirdly, if these two are the same, the limit as x approaches a of f of x equals f of a. So we just need to memorise that and then to be able to apply it. So let's just see how this works with an example. So we've got this hybrid function here. And where did that line come from? F of x equals 3x plus 1 when x is greater than or equal to 2, and f of x is equal to x squared when x is less than 2. And we want to know, is this continuous? So rather than if, we put is this function continuous at x equals 2. So criteria number one, we've got to see if f of a, or f in this case f of 2. So f of 2, can we work out f of 2? Well, which one of these two pieces of the function does it behave like when x is equal to 2? Well, this is x is less than 2. This is x is greater than or equal to 2. So it's going to be behaving like this part. So it'll be 3 times 2 plus 1, which is equal to 7. And now we apply criteria 2. Don't forget we've got to test until we find that one doesn't, and if all three are met, well then it is continuous. So we've got to find what happens as x approaches 2, the limit. So the limit as x approaches 2. Now we've got to do this because this is a critical point where the graph changes its nature. So it behaves like a linear graph up until including 2 and then x squared afterwards. So the limit as x approaches 2 from the negative side. So we're going to come in from the left-hand side of the graph of f of x. Now we've already said that as x is less than 2, it behaves like x squared. So it's going to be 2 squared, which is equal to 4. As x approaches 2 from the positive side, f of x, so x is 2.001 or something like that, it's a bit bigger than 2, it's going to behave like the linear graph. So it'll be 3 times 2 plus 1, which is equal to 7. Now because when we go from the left-hand side or the negative side of 2 and we come in from the positive side and we get two different values for the limit, therefore no limit when x equals 2. So it does not exist. So we don't even have to go to criteria 3. Criteria 2 is not met, therefore f of x is discontinuous. Another word for not continuous, discontinuous at x equals 2. And you can see x is less than 2. That's normally regarded as a continuous function for all values except when it's in a hybrid like this. So 3x plus 1, if you just grew y equals 3x plus 1, you're going to get, going through 1 there, you're going to get a graph that is continuous all the way. So, but at 2, it changes. So that's the graph up here, x is greater than 2, y equals x squared. So we're going to get a hole in the graph just here. And so it is discontinuous. And so that shows you how to test for continuity of functions. 3 criteria all have to be met, and you need to go through it and do it bit by bit. And as soon as you get one that doesn't work, then you know the function is discontinuous at that value.